Hello and welcome to this video on how to create this force field like material. Now you can see that it's going to have a number of different elements to it. We've got the background pattern, which is pulsating. We've got at the edges a kind of a sort of mask coming off of it, and when an object passes through it, it creates a kind of burn-in effect as it passes through. Now I'm going to break this down piece by piece as we go in, but one of the things that you might find interesting is this is a movable, like this. We are not tied to the UVs of this object, so you can see I can expand out or shrink in, and we'll keep the pattern in the background, and it will maintain its elements to it. Now you can actually see that this is only on one axis because it is I've just stuck this on a cube that I'm rescaling, so the actual mesh that this plugs into doesn't matter as much. It would only really work on square-ish objects. And another note, this is not going to be a step-by-step guide on how to create this material. I'm actually going to provide the finished material in the details panel so that you can grab it directly. What it's going to be more is I'm going to go through an explanation of how each part of the material works. So if you want the full material, just copy and paste it from the description. And now I'm just going to be walking through piece by piece how to put something like this together. Right, to start with, this is what the whole material will actually look like at this point. Now I am going to go through each one of these commenting boxes to sort of show you how each of them work, but there's a couple of things that are worth noting at the beginning. The first thing is the material setup. So if I select the material, you can see that we have, this is a surface material and its blend mode is additive and unlit. Now it is quite a costly material, primarily, so if I jump into the shader complexity, primarily because you can see through this, we're going to have to be calculating what's behind, so it's got the same problem as all translucency has. This needs to be done after we've calculated the screen as it is. Now, having said that, it's not that expensive. So you can see that we're only in the low reds here. We're not coming up to the whites. If you get a lot of these together, it would be, but it's relatively cheap. Ish. Okay, now this is achieved by using the material domain surface, blend mode additive, and I'm going for the shading mode unlit. Since this is glowing, I'm not too worried about figuring out what the lighting on this is. Okay, and that will hide all of the other nodes, and we're only really looking at the emissive color and the opacity as inputs. Now this is what we're doing to put the whole thing together. Now the emissive color, I am just lerping between a blue and a red, so the red is going to be for the burn in. I'm timesing this by 50 as well, just to give it to make sure it glows. Now I have two different elements here. I have the edge mask and the distance field. These are going to be the bits that are in red, so you can see that they get plugged directly into the alpha here, which will move us over to red from blue. And this is what's going to be, so the edge mask is going to be using the bounding boxes for the edges of the cube, and the distance field mask is going to be how we create that pass-through effect. When another object passes through it, we use distance fields to calculate how that looks. We've also got the pattern mask and the pulsate, so this is our background. And these are all just added together to figure out the opacity. Okay, I've also, throughout this, I am using a lot of scalar parameters. These are useful for two reasons. Firstly, it means that we can expose them to a material parameter collection, or a material instance. And what's great about a material instance, I mean, there's a number of reasons. Material instances are fabulous at getting, so you can create multiple materials using just one parent material, but they're also great for refining numbers. And in order to get the correct look for this, I'm going to need to tweak the numbers, and it's a lot quicker to do it for a material instance in the world, so I can just drag these up and down, than it would be for me to do inside inside the editor. So in order to get the exact numbers, I'm using the material instance, and I suggest you sort of do the same. Okay, so let's go through these materials. So the first thing is, let's grab this top part here. Now what we're doing with this is we are creating, if I was to get this mask, and I'm going to use a second material here just because I want to make it easier to understand this. So I'm going to go for surface, opaque, and I'll go for default lit, and I'm not going to worry about emissive color. I'm just going to plug the numbers that I want directly in. So maybe unlit would actually be better. Okay, so as you can see here, we have the edge mask. So if I was to grab the edge mask and plug that into the emissive color, you can see what that gives us. That gives us on one side a mask which is scaling from the top and the bottom. So how do I go about creating this? And if I was to apply, and I'm going to throw this on the one in the world. So force field 1, there you go. So you can see that the mask that we have here, it scales with the actor as it scales, but this gives us our edge. Now, how do we go about creating this? Well, on the edge mask, if we come up to here, let's have a look at what we have. So the first thing is, if you haven't encountered these before, these are named reroute nodes, and they're really useful to keep your material sort of tidy. So you can see that the local bounds min scaled is going to be used all over the place. So local min scaled here, and also the object scale we're going to use across a number of different places. So I want to make sure that we can reference them in one place. The other thing as well is it makes these easier to understand because they've got a name. I can see here that I'm multiplying by the object scales rather than having to follow back a line to try and figure out what I'm calculating at that point. So it's useful to make the whole code understandable. So we're creating the edge mask here. Now what are we doing? So we have the local object bounds, and we're using this. So if you're not used to bounds, what they are is all objects will have a bound. So all meshes will have a bounds, and these are squares. These are cubes which fit around an object, and these are used to primarily for frustum culling. So you'll often what you'll do is you'll try and detect if an object should be rendered to the screen, or should be excluded from rendering from the screen, if its bounds are not within the view of the frustum. But these are also useful as a way of us getting being able to apply a material to an object, so we can get the top, bottom sides. Because if we were to work in UV space, we were defining ourselves by the UVs, we're not necessarily going to be working with the bounds of an object. So what we're doing is we're using the object local bounds here, and I'm saving them out, and you'll see in a lot of cases I'm multiplying these by the object scale. So the object scale is going to give us literally the transform of how we've scaled an object. but this allows me to do a multiplication so that I can do stuff like, when I make this very, very large, the tops and the sides don't also scale in the same way. We can define a regular edge. Okay, so we're mapping this in the object bound space, and we're using the absolute world position and the transform in order for us to calculate the size of the object. Now you'll see that we've got almost identical code on top of each other, and that's because if I grab this power and plug that into the emissive color, you'll see that we have I'm starting off the multiplication here to use the bounds, which if I plug the bounds directly in, you would see that it would give us a gradient from the top to the bottom. But here I'm using the power to blur it, so rather than it going from 0 to 1, it's actually going to go in a bit of an arch. So the majority of the 0 to 1, so it'll be nearly 0, 0, nearly 0 until it goes up to 1 in a quicker arch. So that's what I'm using the power node for here. And the only thing that this side here is doing is the opposite. So you can see it's doing it on the opposite two edges. And that's why I'm grabbing these and adding them together. So I'm doing the multiplications by the size of it. I'm then using the power to ramp it to the edges. I'm also adding a border size, a manual border size here, so that I can control, so it doesn't necessarily do a drop off to the edge, but it does get close to it. And we're using a scalar value for the blur border mount on these sides. Now I'm then adding them together, and because we are just doing it on two axes, so just on G and B, which would be this is a vector that we're using to represent X, Y and Z. B is going to be up and down, G is going to be left and right in this case. We only want two of these. I'm just grabbing those two values and adding them together, and that gives us our cube edges like this. Now I'm then saturating it to get rid of any values over 0 or under 0 or over 1, and I'm using that as my edge mask. So that's my starting edge mask. Okay, so next up we have the pattern creation. Now I'll show you what the pattern mask looks like. So if I plug the pattern mask in, you can see this is just a number of different circles, and that's because I am using a bokeh texture, so it's just part of the engine, but I'm using this as a texture for you. Now what's interesting is you can see that this is projected in local space, and what would also be interesting is if I apply this and jump into level, you'll see that no matter the scale that I'm working with, the circles don't change in size. They map as we change the size of the object. So we're projecting this in local space. So this is what this calculation is working out. A local space projection UVs. So we're taking the absolute world position. I could probably just, I won't muddle with it, but I probably don't need the Z. Yeah, no, I didn't need the Z. Okay, so I'm transforming it from the absolute world to a local space, and then I'm multiplying it by the object scales. Now we worked this out previously, but this will make sure that as the object gets scaled, we keep a consistent value. Then I'm getting rid of the red because we only really want X and Y. I'm using this for X and Z. I'm using this for the local space projection UVs. So this gives me our projection. Now again, I've got a variable here that allows me to scale the pattern just by multiplying the UVs, and the texture sample, which I'm going to convert to a parameter, which I should have converted to a parameter, and call it texture pattern. So it can be controlled. So you could change this to anything, and so I could drag this down, I could change it to this, and all of the map would be changed to that accordingly. But I like the bokeh, it's just straightforward and simple. Okay, so that gives us our pattern mask. Now, if you watch the material, our pattern is going to be sort of shimmering, sort of fluctuating black in its strength. And that's what I'm using this pulsation creation. So if we drag the pulsation and plug that into the emissive color, you can see what we've got here is this sort of value. Now again, we're using the same UVs because we don't want this to change as we scale the object. So we're using the local space projection UVs. But for this, we're doing a different scale, and we're also panning it. So what panning allows us to do is slowly move the UVs so the texture has this animated sort of feel to it. And again, we have another texture. In this case, we are just using a low-res blurred noise, which is quite good for creating this sort of effect, and it's not too costly. Again, I'm using a power node just to make the effect more extreme, and saturate to get rid of the values above 0 and over 1. So that gives us our pulsating effect. So now, if I was to multiply the pattern mask by the pulsating effect, you can see that these are getting, they're slowly getting different colors as it moves across them. Right, final one, and that's the distance field effect. Now this, if I plug this in, well, this is hard to see. This is harder to see. But what we're doing is we're getting the distance to nearest surface. Now you have to have distance fields on, and what this is going to do is this is going to take a world position, and it is, what other options do we have? Cameras. And it is going to give us a value based on how far away it is from other surfaces. Now I'm dividing this to get rid of the length, and I'm going to clamp this, or I could saturate that. I don't even need that clamp. So, and what this does, if I jump into the force field, now this is where we need another actor. So if I add into the world a sphere, okay, it's not working at the moment. A second. Yeah, it should work. Ah, that's because we are not in translucent mode. So if I grab translucent and now go apply, it's hard to see because the value isn't massive, but as we get closer to this, and it's both being added into the opacity as well, so I'm just going to disconnect the opacity. We can see as I move something through this, the value is slightly changing. I'm going to drag this up so you can see as we get far away from stuff we've got nothing up there, but as I move in closer it takes the distance field of this ball. Now this is where the material instance is really useful, because you really want to rein this in to get the correct effect that you're looking for. But that's what the distance field does, distance field marker. So I think that is everything. So here we're just splitting it out so that we can get the different effects in the different areas, and that's the entire code that's just bolted together. Great, I hope you find that useful.